Okay. Good morning, good afternoon, good evening. Whenever you are watching this video, I welcome you all on behalf of our channel Future Endeavors. Rather, we should say this is a channel that belongs to you all. Okay, so in the previous class, we have been discussing about the chapter called Measurements, Physical Quantities and Measurements that is present in the syllabus of class 7. So we will continue from the last class where we have discussed about how to measure the volume of any irregular solid. Now today we will talk about measuring the area of a certain surface. When you say about area is a basically two-dimensional concept which involves two dimensions. It involves the measurement of two parameters. Okay, so if I consider this board as a plane, so see this board, as you can see, is a rectangular surface, so it should have definitely an area. If I say what is the area, I should be first measuring this length of the board and then measuring the breadth of the board and then multiplying it, we will get the area of this board. Okay, so today's topic, measuring area. Now if I talk about of regular surfaces, means which have a definite geometrical shape. If I talk about such regular surfaces, we have definite formula at our hand present for those surfaces. Okay, like say if I say consider if I want to measure the area of a say rectangle, as I have just been discussing. So if I say that the area of rectangle, so what is the area of rectangle? I think everybody is quite familiar with this formula. Area of rectangle is length L multiplied by the breadth B of the rectangular surface. So area of the rectangle is given by the formula length of the rectangle nth multiplied by the breadth of the rectangle B. Likewise, if I want to measure the area of square, then I have to measure first of all the length of one side of the square. As you know in a square that all the sides are equal length. So if I consider that the side of the square has a length A, then I should be getting the area of the square as A into A, or rather I can say as it A square. So this is the area of the square. Likewise, I can get the area of a triangle. If I think of a triangle, then area of a triangle, so by just representing it by a symbol, area of triangle is equal to, you know, as it is half into base of the triangle into height of the triangle. Okay, so these are some of the formulas of some regular areas, that is surfaces having a definite geometrical shape. Likewise, you can also measure the area of a circle. So what is the area of a circle? Let us see. Area of a circle, if I say that the circle is having a radius r, then area of circle is given by the formula pi r square. Okay, so this pi is having a value of what is the value? It is 22/7, or I can refer it to as 3.14. Okay, so this is the area of a circle. Likewise, I can have the formula of all such areas which are having a definite geometrical shape. I can have the area of a parallelogram, I can have the area of a rhombus. Likewise, I have many shapes which have a definite geometrical definition, and thus we can have the exact formulas which help us to easily find out the area. But what about the area of any irregular surface which do not have a definite geometrical shape? Like you say, when I consider the surface of a leaf of any tree, a big tree, okay, say a banyan tree or say a mango tree, the area of the surface of leaf, as you know, does not have a definite geometrical shape like a square, rectangle, circle or semicircle or anything like that. So what is the method for measuring the area of the leaf? So I should just change the heading a bit. Measuring the area of irregular surfaces. How can I measure that area? Okay, now let us see. So what is the procedure for measuring the area of irregular surfaces? See, for measuring the area of an irregular surface, what you need a graph paper. Okay, you need a graph paper. You all know what is a graph paper. You need a graph paper which are having some grids, means some square boxes. Okay, you know a graph paper looks like something like this. It's a like this, a big sheet of paper. Okay, big sheet of paper. Now, and you have like this horizontal lines and also vertical lines. Okay, like this you have square grids. These are the square grids I am referring to as. Okay, so this is the what do you say, this is what a graph paper looks like. Okay, so for measuring the area of an irregular surface, you need the graph paper. Now this graph paper can have their length and breadth in terms of either centimeter or millimeter or inch. Say if I say that the what is the area of each box, please do just listen it carefully, because you will be needing this information in actually calculating the area of an irregular surface. Okay, so if I say that what is the area of this particular one box, say, so this, if I say I am saying that this is a graph paper of centimeter graph paper. Okay, this is a graph paper, okay, having their dimensions in centimeter. So this is a centimeter graph paper. This is called the centimeter graph paper. Okay, so when I say centimeter graph paper, actually what is meant by that, each box, so this box is having a length of 1 centimeter and this breadth and length, both of these boxes are 1 centimeter. So if I say what is the area of this small box, then area of this small box turns out to be, so area of small box, I can say, or rather I should say square, is equal to 1 centimeter into 1 centimeter, that turns out to be 1 centimeter square. Okay, so it is the area of each small box. Okay, so please be careful about the unit. So please note it down. If you have not noted it down, please pause the video and just copy whatever information has been given on the board. Okay, so now let us see how we can measure the area of any irregular object. Okay, so now I am just rubbing off the information. If you have not noted it down, please pause the video and do note it down. Okay, it is important for the calculation or for the next few steps that I am going to show you. Okay, now let us see. When I am thinking of measuring the area of an irregular surface, say I have said that I am interested in measuring the area of the surface of a leaf. Okay, area of the surface of a leaf. Okay, so let us see how can we measure the area of the surface of a leaf. So see here, okay, so let me just draw a bigger graph paper for you all so that it is easy for you to understand. Okay, so something looks like this. So these are the grids, okay, present on the graph paper. Fine, okay, and like this. Okay, fine, and you have some horizontal lines also as well. Okay, so these are your lines, horizontal lines. Okay, now say we want to measure the area of a leaf. So say leaf looks like this. Say we are taking a big leaf like this. Okay, it's having an area of like this. Okay, there is a twig of the leaf. We don't need to measure the twig. Okay, so now you want to measure the what is the area of this particular leaf. So this is just an arbitrary calculation. Don't go into the specific values that I am referring to. This is an arbitrary calculation. I have just taken an arbitrary value, arbitrary shape to demonstrate you how to measure the area. Now you see, first of all you need to count. When you place this leaf on a graph paper, just draw an outline of the leaf and remove the leaf. Okay, now you need to measure how many boxes are present within this outline of the leaf as a whole. What I mean is, see, if I see, so this box is totally inside the leaf. Okay, this box is totally inside the leaf. Okay, this box is totally inside the leaf. This is inside, this is inside. Likewise this. Likewise this and this. Likewise this this and this. Okay, now these are the complete boxes that have, oh, there are one more, there is one more, this. Now these are the complete boxes that are present within the boundary of the leaf. So first of all I would like to count how many full boxes the leaf surface or the leaf outline covers. So I writing at the side number of full boxes. So what are the number of full boxes? If I count 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 and 24. So this turns out to be 24. I am not taking this box. See, specifically a big part of this has been left out of the margin of the leaf, so I have left it out. So there are total 24 boxes. Okay, now we'll again also take those boxes into consideration which are at least more than half present inside the leaf outline. More than half. Okay, so I'm just not giving it a full tick, rather I'm giving a half tick. Okay, so more than half, if I say half or more than half. Okay, so this box is half or more than half, this is more than half, this is not, see, this is more than half is outside the leaf surface, so I'll not take it. This one is okay, this one is, we will not take this leaf. These boxes, see, are less than half present within the leaf surface, so we will not take those boxes. This will be all left out. This will be also left out. In fact, this is okay, this is quite half, so I can take it. Any more box? Okay, this is okay, and any more box present? Yes, this one, and I can take out this one also, as it is almost half. Okay, almost half. So like this you count the number of boxes which are at least half or more than half present in, not the full boxes. So I write it here as the number of half boxes. Okay, half boxes. So let us count what are the number of half boxes. So it's 1 2 3 4 5 6 7 8 9 10. So these are the 10 half boxes. Okay, now while calculating the area, we will add up the full boxes as well as those boxes which are at least present half or more than half in the outline of the within the outline of the leaf. Okay, so I think it is clear to you all. We will not count those boxes which are present half, okay, in the present less than half in the margin of the leaf. Okay, so I am just erasing of the diagram so that I can show you the calculation. Now see, I have said that area of each box is 1 centimeter square. I have said, okay, I am just noting it at the side. Area of each box equals to 1 centimeter square. Okay, this information will provide it to you. Area of each box is 1 centimeter square, or it will be given what the graph paper has dimensions, either it is a 1 centimeter graph paper, 2 centimeter graph paper, 2 millimeter graph paper, 1 millimeter graph paper, or I can say 1 inch graph paper, like this it will be given. So whatever be, you can calculate the area of each box. Now, so I think I have noted it down. I am rubbing the figure off. Okay, so now if I see what is the total area the leaf that is covering, I can say that this leaf actually covers an area of, what will be the calculation? Okay, see, as I know, area of each box is 1 centimeter square. So first let us see. So total boxes included, total boxes present inside the leaf margin. Okay, inside the leaf margin, it is actually 24 plus 10, so it's 34. Now you know area of each box is 1 centimeter square. So what will be the area of 34 box? So area of 34 boxes, rather I should say, is equal to 34 into 1 centimeter square. That turns out to be 34 centimeter square. Okay, so this is the actual area of leaf. Although we have left out some boxes, it is quite accurate to say that this calculation, but that this calculative method is actually okay. So I can say that area of the leaf is actually 34 centimeter square. So this is the area of the leaf. Okay, this is the area of the leaf, 34 centimeter square. So in this way you can actually calculate the or measure the area of any irregular surfaces that you have. Okay, fine. Let us see. Now if okay, so I hope it is very clear to you all that in this way you can measure the area of any irregular surfaces. Okay, now quickly moving on to the next topic, we have a new physical quantity that we have not discussed yet, and that is density. So let us see what density is. You have a just brief discussion. The scope of your syllabus has given us a very limited area to discuss about the density, although it is an introductory part. You will be reading about this in details again in class 8. So just if I say what is density, so next topic, make heading density. Okay, so density, what is density? Now you see, we have said that each and every matter do have a certain definite volume as well as a certain definite mass. Now when I consider, say, an small iron nail, it has a certain volume, a certain mass. If I consider another say a large cube, okay, or say a rod. You have seen rods that are used in construction of houses, that are also made up of iron, but it has a different mass, different volume. So likewise, actually, although with substances which are made up of the same material, but they are having different masses and different volumes. But if I consider this property, density, then this property you will see that it is same for the same material. That is what I want to say. The iron that makes up the nail will have the same density as the iron that makes up a cube or the iron that makes up a ship. In fact, this density is a property of a material, that remains constant. Property of material, any material I can say, that is actually constant. Okay, it does not change. Density will not be changing. Density will be remaining constant. When you are taking a certain material, okay, for a particular temperature, I have to mention it that for a is constant for a temperature, particular temperature. Okay, if the temperature changes, then the density of the substance can change. If the density of a substance changes, so I can, if If the temperature of the surrounding changes, then I can say that the density may change. So this is constant property of a material for a particular temperature. Now what is this density? It is very simple. If you just take any object, measure its volume and measure its mass, and take the ratio mass by volume. So I am just noting it down. If I just, density is given by, you measure the mass of an object, divide it by the volume of that particular object, you will get the density of that particular object. Okay, so mathematically we can say that density is equal to the ratio of mass and volume, or in simple terms I can say, if I divide the mass of a particular matter or substance or any object by its volume, I will get the density. Okay, so density, so how can I define density? Density I should say it is defined as mass per unit volume, So density is defined as mass per unit volume. It is having the SI unit. What is the SI unit? I can say, please note it down, SI unit. Okay, SI unit is kg meter to the power minus 3, and CGS unit is given by gram per centimeter to the power minus 3. Okay, so these are the units of density. Okay, so I think it is clear to you all. So different substances have different densities. If I take iron, it has a certain amount of density. If I take aluminium, certain density, steel, certain density. So it has different substances, different densities. So in this way you can actually measure the density of any substance that you have taken. Okay, so likewise I am just for information I am just saying, just do remember the density of water, particularly water. The density of water is very important because we need it in many calculations. So just remember the density of water. If I say density of pure water, actually I should say density of pure water is equal to, the value is equal to, what is the value? It is equal to 1000 kg per meter cube, okay, or 1 gram per centimeter cube, and this density is at, remember the temperature, this density of water is at 4 degrees centigrade. This is very important. This information is very important. Please do remember, students, please do remember, this is important, quite important. So I have to remember this particular information. I do not need to remember the density of any other substance likewise, but this is important for you, so please do remember it. Okay, so this is density of water. Okay, now quickly moving on to the last topic of our today's class, is the speed. So I think you have all noted it down. I should rub it off. Okay, if you have not noted it down, please do pause it and note the topic. Okay, so now quickly moving on to the last topic that you have in your syllabus, it's speed. We often rather use this term very often, speed. What is speed? So we say that the bike or the car is moving at a high speed. Okay, and if I say think of any cart driven by a cow, it has a very less speed. And if you think of your bicycle that you are driving, it has a speed, moderate speed. Okay, not too fast, not too slow. So what is speed? Now speed is actually defined as the mathematical, I can say that it is the distance traveled by an object by the time taken to travel that particular distance. This is the speed of an object. So if you want to know the definition, I should say speed is defined as distance traveled by an object in unit time. Okay, so what are the SI units? So if I think of the SI unit, So SI unit of speed is actually meter per second, and CGS unit of speed is actually centimeter per second. Okay, so this is speed. So whenever the object travels a greater distance in a smaller time, it tends to have a larger speed. So speed, I should say, is actually directly related to the distance. The more the distance it travels in a particular time, more is the speed, and it is inversely related to the time. Say you see, when the denominator is larger, your speed automatically gets reduced. So when you travel a certain distance in a more time, actually the speed of that object is less. So here we end this chapter. I think all of you have understand. So what do you want to tell about, what do you mean about the speed or the density, or how you can calculate the area of a certain irregular substance? I think it is clear. So we will end this chapter here. Next we will be coming up with the next chapter. Okay, till then, before saying goodbye, I would again like to say, please do subscribe our channel, please do watch our videos and share our channel. Also please press the bell icon for further notifications of such videos, wonderful videos that will help you to understand science in a better way. And please do support us, and I am already thankful to you all for supporting us in this manner. So I think I will be meeting you up very soon. So till then, goodbye, thank you. Okay.